see my screen now? So we are talking about the spanning tree ports. So what are the ports available in the spanning tree? Root port, right? Designated port, blocking port, that we call it as non-designated port, backup port, and alternative port. Alternate, not native, alternate port. So these are the ports available in spanning tree, different types of ports we call. So designated port, root port and all, you know. What is blocking port? That by default puts the port itself in blocking state to prevent the loop. Okay, but it will not forward any network traffic. It will be in listening state. When you see the port status by logging into the switch, okay, show interface or show interface brief or show interface status, these three commands will be used to get to know about the interface status. Show interface brief, show interface status, or just elaborated one is show interface. So from these show commands, you will get an output mentioning what exactly the port status physically. So physically is up or down. You will be able to get, you'll be able to know from these interfaces. But blocking port does not mean the port is down. Okay. Say if fast Ethernet 0/1 is in blocking state as per STP, doesn't mean the port is down. The port will be up. Physically, it will be up. LEDs will be blinking, but port will not send and receive any network traffic. It will be in listening mode. Okay. Backup port. So what is backup port? By the name itself, it's a redundant port to reach the root bridge, ready to take over its forwarding condition at any point of time if the designated port fails. Right. So that is the backup port. Alternative port is again a backup for the backup port. So backup path on the switch is not part of the active topology. So that is also one of the, say if the backup port is also down, then alternative port will come into the picture where it will start forwarding as if it is a designated port. Okay, so these are the different types of ports available in port status. What are the different port status? So how during the process of spanning tree election, or as soon as when the switch is turned on, the port will converge into different states. Okay. Before the port physical status comes online or up, before the port has a green LED blinking, the any physical port on the switch will come across different status, different stats. Okay, different status. It will come across each step one by one, and then it will come to forwarding. So what are those port stats? Those are, first, it is the port will be in disabling mode. Disabled. First, initially, as soon as the switch is turned on, the port will be in disable. Then it will be in blocking state. So what is the difference between disabling and blocking? What is the difference between disabling and blocking? So disable is the port is physically down. It cannot send and receive network traffic. It is not going to send any BPDUs, send and receive BPDUs. It's nothing. It's like physically the port is down. That is disabled state. Okay. Blocking state is for port is ready to send and receive BPDUs alone, but not the network traffic. That's the difference between disabled and blocking status. Next is listening. Listening status, what will the port will do is, it will try to change, at this state, the port will try to change from blocking to listening, where it will start to listen if there are any other switches, root bridges or non-root bridges trying to send any BPDUs. Okay, sending of BPDUs, whether it's able to listen, it's actually is ready to listen any BPDUs that receives on its port, but it will not forward anything. It is ready to listen. It's not also start to listen. It's listening, ready to listen or receive any BPDUs. Okay, that is listening state. Then it is learning. Learning state, the port will actually learn the MAC address, and it can also send and receive the BPDUs. MAC address of the device which is connected to that specific port. PC can be connected, switch can be connected on a port, or router can be connected, or any printer fax machine, anything can be connected. But at this stage, it will start to learn the MAC address. If the switch is connected, then it will learn the switch MAC address. And it will try to learn to which port the switch is getting connected. Yeah, sorry for that. Okay, so that is learning. When the port listens to the MAC address, what is being learned or what is being sent on that port, and it also receives and sends BPDU as the learning port. Next is forwarding. We already know what is forwarding is. So forwarding is actually the state when the port actually redirects into forwarding stage, when it will start to receive the network traffic. Okay, these are the STP protocol port states or stats. Okay, so
For
next,
every status, it will take around 10 seconds of time. Or
yeah, the next is the timer, which I'm going to explain. Okay, so blocking, when the port is in blocking, it actually takes 20 seconds to move to the next status. So blocking port will be in blocking state for 20 seconds. It will actually will not learn any MAC address, or will not forward any frames, or will not send and receive any BPDUs. For 20 seconds, this means that all the ports in the root bridge and not non-root bridges will go under each status one by one, and then only the network convergence will happen fully. The network will come online fully. Network in the sense, or switch will come online fully. Okay, so it will take 20 seconds. Listening will take around 15 seconds is the timer for a port to be in listening state. Next, learning will be in 15 seconds again. And forwarding, immediately go to forward. Immediately, if the switch to forwarding starts to send receive data. These are the timers for each state. Okay, what would be the benefit of having spanning tree protocol to get implemented in a network? So it blocks the path that causes the loop by default. It increases the network stability, right? And also it manages the network redundancy, and also it optimizes the route, like when there is multiple paths to send data from source A to B, it will optimize and send data to the best route, like how routing does it. It also sends the data traffic to the best route that is there in the network. So those would be the advantages of STP. At the same time, there are some disadvantages as well. So what was the major disadvantage is the convergence may be slow, causing network delays. Convergence is very slow, like update. Example, like there are like 20, 30 switches in the network, okay? STP is configured and there's a power shutdown, a plant maintenance. So all the switches are down at the power shutdown time duration. And as the maintenance is over, with the network administrators turning on each and every switch. The switch itself to come online with all the ports in ready state will take more time actually. Okay. And similarly, if there are any network ports that is down and it is coming up, or somebody is working on a real-time network where they are trying to add a network switch, and say in a 30 switch network, he is trying to add one additional switch, 31st switch in the network. That switch will actually will impact the network by, like, there would be a topology change. STP topology change will be there. The port election will change. So that convergence is also slower. There will be network delay during at that time. Network delay means network will be slow. If somebody is trying to access internet or sharing any file, they will free a glitch in the network. So that convergence is slow when STP is configured. If, say, for example, if STP is not there in any switch, okay, then switch will come immediately online, the ports will come immediately up. So everything will happen immediately within a fraction of seconds. But you have to see the difference. You will be seeing the difference when STP is configured in a switch and STP is not configured in a switch. There will be difference. So that is the major disadvantage of having STP. But nevertheless, there are many advantage benefit of having protocols, STP protocol also. So we are using that, knowing this would be a major disadvantage. There are different versions or types of spanning tree protocol. So the spanning tree protocol, which we are talking about now, is we call it as a normal spanning tree protocol or classic spanning tree protocol. Okay. So a normal spanning tree. Okay, before that, I'll just show you one more thing. So yesterday you were asking about how the lowest MAC address is being elected for the root bridge, right? Okay. Switch. There are three switches: switch 1, 2, and 3. By default, the priority is same for all the switches until unless we manually change the priority. It is going to be 32768 plus that is the bridge ID, we call it. Okay, the bridge ID is nothing but the priority plus the MAC address. MAC address of each switch is being listed over here. So out of this switch, which MAC address do you feel is the lowest one? So which one is the lowest one?
You should convert the hexadecimals into binary and check, or we need to convert the hexadecimal into binary and check, or
So which one? Yeah, you need not convert actually. That is not. It's an easy MAC address only. So there's no conversion required. By just have a look and let me know which would be the lowest MAC. Yes, one. Yes, right. So yes, one is obviously having the lowest MAC. Because the other MAC starts with 00 D 003 006. So out of these three, 3 is the lowest. So S1 is the lowest MAC. So S1 switches will be elected as the root bridge. And on the root bridge, all the ports will be in forwarding state. And on the non-root bridge, there would be designated ports in forwarding state and one will be in blocking state. So likewise, this is how the election will happen. Okay. So here in this picture, that doesn't mean both the ends of this link should be in blocking. One will be in forwarding. Okay, either one should be in forwarding, and this has been elected based on the port cost. Okay, port cost or MAC address of the switch. So this has been elected in that way. And if you go to show spanning tree command, okay, show spanning tree command, you asked where the MAC address will be present in the switch. You can just hit show spanning tree. You will get an output. Will show the priority and the MAC address. The cost we were talking about for fast Ethernet is 19. That will also will be the output. Port status, role designated. Port status, currently it is forwarding, designated port, right? All the ports in the root bridge will be in designated state. So it is designated. All right. So coming to the different versions or different types of spanning tree, classic model is there. That's the original STP with the IEEE standard 802, 802.1D. I'll write up STP. It's 802.1D. Next is RSTP, that is Rapid STP with the standard of IEEE 802.1W. That's the IEEE standard. We call it as RSTP. So RSTP is the next version of STP. Okay, that actually addresses the convergence issue. So where during the network convergence, when it will happen, when there is a change in the network, right? When there is a change in the network convergence will happen, and that time gap issue has been rectified and enhanced with the BPDU exchange packet, and that has been corrected in rapid STP, right? So that is RSTP. Then MSTP, multiple STP that comes with 802.1.s, 801s. Okay. So that MSTP is actually like it's been an advanced version of rapid STP, which has multiple VLAN into some spanning tree to reduce the processing of the switch. So multiple VLANs can be mapped, okay, based on instances. So VLAN, say I have VLAN 1, 2, 3 to up to 20 VLANs. So we can configure an MSTP where VLAN 1 to 10. For VLAN 1 to 10, this is the root bridge. For VLAN 11 to 20, that will be the root bridge. The backup or the primary and the backup concept, right? And with HSRP. So the primary switch will be having VLAN 1 to 10 as the root bridge, and the secondary switch VLAN 11 to 20 will be in the root bridge. So like that, we can split the root bridge role as well by creating multiple VLAN instances. That feature is available in multiple STP, that is MSTP. Next is per VLAN. Per VLAN STP standard is 802.1D. 802.1D. Okay. So the all the three which we are talking about earlier, STP, Rapid STP, MSTP, or non-proprietary protocol. It's not Cisco's, but per VLAN spanning tree plus is it's spanning tree plus is STP. STP plus Cisco proprietary protocol. Okay, here also we can configure separate STP instances for each VLAN in the network with an enhancement. So that with that enhancement, actually my MSTP and per VLAN is similar only. Is similar only, but it's a Cisco proprietary. The MSTP is a non-Cisco proprietary. The advanced version of per VLAN spanning tree is rapid PBST. So that's the advanced version of per VLAN. It's also a Cisco proprietary with the standard 802.1W. But if you see this one, rapid PVST plus and rapid STP. This is the next version. We'll have the same IEEE standard. This is a non-Cisco proprietary. This is Cisco proprietary. And this is just example, the advanced version of rapid STP. Okay, so it also like works on separate STP instances for each VLAN that can be created, enabling a faster convergence time. The convergence time will be very fast. So how these protocols, how these different versions of STP can be enabled on the switch? Okay, how these can be enabled on the switch? This just one command like in the configuration mode. Just say spanning -tree mode PVST or spanning-tree mode rapid mode MST. So by this we can configure those specific spanning trees or protocol. We need to enable first. We need to enable spanning tree, right? With this one command, will do the spanning tree protocol will be enabled on the switches. It's in the global configuration mode. So next is we want to talk about STP tuning. Okay, how we can fine tune the STP process. Whatever may be, whether it is a rapid PVST or per VLAN or MSTP. Okay, we want to fine tune the STP processes. Okay, for which we can see, though the spanning tree is enabled on the global configuration mode, it applies on the whole switch. That's it. That's it. The job is done. But still, we can fine tune. We can add few more spanning tree features on the switch ports to have a fast convergence, to block the BPDUs, or to enhance an additional root bridge should not come into the network. Okay, so there are many things actually to when we fine tune. Okay, so we are going to fine tune with certain features that is already available in spanning tree. Okay, so first we want to talk about spanning tree port fast. I'm just typing the command. Spanning-tree port fast. Okay, so port fast is one command that should be enabled only on the edge ports. Edge port is nothing but edge port is nothing but an access port. Okay, spanning tree port fast should be enabled only on the edge port or access port. So it should not be enabled on the trunk port. If you enable by mistake on the trunk port, then the network or the switch or the connectivity will be lost. Okay, so this feature actually what it does is it bypasses the normal STP initialization process. The initialization process we were discussing about the port going into different state, right? Disabling, blocking, all these will take at least 35 45, 50 seconds for a port to come online in forwarding state. So this spanning tree port fast command will actually bypass all these STP initializations process of a port. So when this port fast is enabled, the STP will consider that port is as a designated port, and immediately it will take that port into forwarding state. Okay, without going through blocking, listening, and learning. Immediately it will go through the forwarding state. Why this is so important is, as we discussed earlier, when there's a power outage, the switch will go down. I mean, the switch will be powered off, and when it turns on, it normally takes more time for each and every port. So I have 30 switches in the network. So all 30 switch ports will have to come online. Then the STP process election will happen. Then the root bridge will be elected. So much of time will take to actually reach that particular switch itself. So if you give a continuous ping for a switch IP after the power outage, or after when the switch is powered on, so you can see you need to wait for more time to actually bring the switch online. But by enabling a port fast command, the port will immediately come up. So this will be an advantage when the switch port is getting connected to any of the server. So actually port fast should be enabled on the edge port. That is nothing but an access port. So the access port, a PC, laptop, server will be connected on access port. So if the port is connected with servers, yes, there will be a major advantage where the port will directly go into forwarding state and the server will be online immediately. This is actually an advantage when there will be a plant maintenance, or when the administrator is trying to swap the server connected cable, or server itself is gone down and we want to bring it up. So then many instances it will be helpful actually. Okay. So by default, uh, blindly you can enable spanning tree port fast on all the access ports alone, not on the trunk. On the access ports alone, you can easily enable port fast. This is one default configuration every administrator will do. Next is the remaining commands for STP tuning commands are all optional only. If it is required, we can do it. If it is not, it's not mandatory, but it's optional. Based on the requirement, network administrator can configure those commands. Spanning tree root guard. So spanning tree root guard, by the name itself, it says root guard. So if this command is enabled on any of the switch port, what it will do is it will prevent the switch from becoming a root bridge by blocking the ports that receives a superior BPDU, right? And entering into a root inconsistent state, ensuring network stability. So that means, say fast Ethernet 0/1, I've configured spanning tree root guard enabled. But by mistake, if someone or some IT engineer for some outage has happened, is trying to connect any additional switch to that port, a fast Ethernet 0/1. So what will happen? That port, by having a root guard enabled, it will prevent that switch becoming a root bridge. Say if that additional new switch which is getting connected has a low MAC address, the MAC address is very low. So what will happen if you introduce any switch in the network? It will based on the bridge priority, bridge ID, it is having a lowest MAC address, and soon it will start again the election process, a spanning tree election process. Again, the network connectivity will not be there for any users during the election process, spanning tree election process, and that switch, the newly added switch will have to become a root bridge, right? So to stop that, we are configuring root guard. Okay. And also intentionally also there would be someone who wants to hack the network will try to configure an additional switch and put it in the network on a free port, on any free port. Say in a switch, a fast Ethernet 0/1 to 20 is used. Fast Ethernet 0/21, 21 to 24 is not in use. Not in use means the port are already down and does not have any configuration. Okay, it does not have any switch port mode access, switch port access trunk or spanning tree. It does not have any configuration, just a blank port. So that port easily can be connected, used for any additional switch to get connected. So you can connect a hub or you can connect a switch. Or when the hacker wants to connect a switch, what he'll do, he will pre-configure the switch in such a way it should have the lowest bridge ID. So he can reduce the priority. He knows 32768 is the bridge priority by default. He can change the priority to 4096. So it can, multiples of 4096 can be modified in the bridge priority field. So with MAC address, he cannot do anything. He can change the bridge priority 4096 and introduce that switch in the network. He is getting connected to port number 20, which does not have any configuration. Obviously, that will come into the election process of spanning tree and to become the root bridge. So this will disturb the network. This is one way. See, this is one way of hacking a network. So the hacker's main motive is what? He wants to hack something in the network resource, or he wants to bring down the business. That's the only motive of an actor. So if the business is down for 30 minutes, 1 hour, then that is what he wants to achieve and that is done, right? So to avoid that, we have to enable a root guard command. So this will prevent the switch from becoming a root bridge, and also it will not, like it will, even though if the superior BPDU is being sent for root bridge election, this port will go into root inconsistent state. So you'll get a switch log itself saying this port number FA to F in fast Ethernet 0/20 is root inconsistent state. That means, okay, something is getting connected there. We need to either manually configure shutdown command in that switch or manually remove the cable from that port. This is one way of preventing the root bridge.
How we can reduce the default value?
Default value of what?
Priority.
Priority, bridge priority.
Yes.
Yeah, there's a command, spanning tree priority, some priority number. If you give a question mark command, you will get the priority. I can get you the command now, but I'm just telling. You can change the priority alone.
Okay, once can you tell that?
Sorry?
Yeah, once can you tell the command?
Yeah, I'll let you know 1 second. Okay, so this is the command. You need to enter any VLAN number, whichever VLAN that is active in the switch. Enter the VLAN number with priority. Whatever priority you want to change it, and then hit the command show spanning tree. You will get the output with whatever configured, whatever you have defined in the priority.
Yeah, first line in global config and second line in privilege mode.
First line is global. Whatever I'm entering is in the global config. Okay. The tuning
second
command.
line in privilege mode.
Yeah, privilege mode. This is in the privilege mode. And these for STP tuning commands, what I have given is should be under interfaces. Global config, go to the interface, fast Ethernet 0/1, and then go for a spanning tree port fast. Then
we should assign IP address also for the interfaces.
No, we cannot assign IP. It's a layer 2 port. You cannot assign. No. You cannot assign
No, this is for switches.
switches only. Yeah, switches only I'm talking about. But layer 2 switch, in the layer 3 switch, okay, there are switches which is layer 2 and layer 3. As earlier in the first class where I mentioned, IP routing is one command where it's a layer 3 functionality on the layer 3 switch. It is configured for inter-VLAN routing, VLAN inter-VLAN communication between two different SVIs, switch virtual interface we were talking about in the first class, right?
Yes.
Yeah, so on that switch,
And layer 2 we
we
can
can
do
actually
basic.
configure a normal layer 2 port as a layer 3 port by the command say gi0/1 is the port which I want to assign an IP address. Then I have to hit no switch port and then enter IP space address.
Hello.
Yeah, yes, I can hear you now. I think you got disconnected twice.
I don't know what happened. Yeah, okay.
But I was there in the link actually, okay, in the link.
Okay. I don't know. Maybe some issue.
Okay, so what we'll do, we'll just pause here. Okay. But anyways, if I am going
Okay.
to the topic, if the time will not be sufficient, so we'll pause here. We'll just
Yeah. 1 second. Like, just can you summarize whatever topics you have said on today's class? Like, I'm writing notes, but
on the
the one.
introduction, we were talking about VLANs and all, right?
Okay,
How
VLANs
to
is
create
done.
VLAN.
Just cross checking what I wrote. What?
You'll be able to see it in the screen.
Yes, yes. Just go down a bit. Yes. Yeah, this part I wrote. Yeah. Like, I want one help from you. Like, can you share notes of the with the definitions of server, client, and transparent? You know, I'm
Yeah.
just and yeah. Can you go down a bit?
Yeah, I'll put the definition. Exact definition I'll put in the notes.
Yes, and these also these ports. I've just written down the names, but I'm unable to write down the definitions
Okay.
while you're teaching.
Okay.
You're teaching well, but if I want to study after 1 week or 2 weeks, I can't just see the names of it, right? So I need some definitions,
Yeah.
and
That's
commands.
initially it was like that also when I was attending class. So uh, for any new topic, when we go for classes and all, it'll be difficult to write notes. So I understand that. Yeah, I'll try to get some notes.
These topics actually I have idea also. So that's
Okay.
why I'm just writing down the headings. That's it. But I
Okay.
want a good material so that I can read after even after 1 month. If I want to read, it will be helpful for me. So
Okay.
this topic and VLAN. Can you go down a bit? Yeah.
Today's
Yeah,
topic.
these parts and all. Yeah, I know. And
Yesterday
this,
we
yeah,
were
yeah.
talking about
This eight
network
not
redundancy
two
and
and all.
yeah.
Those what does 802.1 or something? Those standards and all.
Standards, yeah, IEEE standard.
Yeah, those standards. Actually, I don't know this. This is new for me.
Okay.
So if you can share what are these, it will be helpful. I
Yeah.
understood what are these now, but I just want to read again. I want to because
Yeah,
all these things will
yeah, I understand. You just was able to understand whenever I teach, but you want to refer something, you need some points to refer.
yes, all these things will easily forget. Mm, this topic is only like that. The whole networking.
But with the class, you're good with the class, right?
Yes, I'm good with the class. I'm understanding everything.
Okay, fine then. It's
And
only a
actually,
problem.
this
I so will
STP,
try to make up some alternative for the nodes.
Yeah, STP tuning also.
Yeah, STP tuning only 2 covered. The remaining we'll cover on Monday.
Okay, what else? What other topics are left?
In STP, we've seen port fast, root guard, then BPDU guard is there, BPDU filter, loop guard. Those and all are
Okay.
there.
After this, you'll go to next topic.
After this Ethernet channel,
Okay.
then we also have RSTP and MSTP. A little bit of RSTP and MSTP alone, we will discuss with the difference between both of them.
Okay.
And then we'll move on to routing.
Okay. Yeah, got it. So, what you can do is you can share the definitions at one point and then the Cisco syntax also.
Okay.
Yeah, I want to practice them.
Okay.
So after practicing, if I find any difficulty, I'll share the screen and I'll show you. I'm getting an error.
Okay.
Excuse me. Yeah. And like you understood my point, right?
Yeah. Got it.
And yeah, I'm good as of now. By Monday, can you share it or?
Yeah, Monday I'll try to share it.
Okay, thank you.
Yeah, thank you. We'll meet up Monday then.